Welcome to the Kubtec web content for the 2021 ORS meeting. In this video, we would like to introduce you to our cabinet X-ray products and show you how they are being used in orthopedic research. We will be presenting a demonstration of the user interface for high-resolution X-ray imaging, blending our high-resolution X-ray images with optical images of the sample, DEXA measurement of bone mineral density and body composition, and finally, 3D tomosynthesis imaging on a mouse specimen. You will also hear from some of our customers on how they use Kubtec cabinet X-ray systems in their research. Here you can see a high-resolution image of the hind leg of a mouse with a surgical pin. This image was obtained at 3 times geometric magnification by the team at Rutgers University on a Kubtec Expert 80 system. Let's quickly examine how this image was created on the Kubtec system. Here you can see the user interface of the Kubtec imaging system. This is where all the data entry and specimen viewing is done. If the study is new, you enter and save a new case. We are going to call this case ORS Demo. Kubtec cabinet X-ray systems are extremely easy to use and no special training is required. You open the door of the cabinet, place the specimen in the center of the imaging area, and close the door. If the case is part of a longitudinal study, you select the case the session is being added to and select the Acquire button. The system simultaneously acquires an HD optical image and the X-ray image of the specimen. These two images can be viewed individually, or Kubtec's proprietary blender feature can be used to combine the X-ray and optical images together to give a comprehensive view of the interior and exterior of the specimen. Kubtec systems that have Digimus software can be used to obtain BMD and body composition from the sample. Determining body composition requires a dual-energy DEXA acquisition. The analysis of the acquisition data gives fat, lean, and bone values. The high-energy acquisition can be used to measure the region of interest, ROI, bone mineral density. If radiation exposure to the phenotype is a concern and only ROI BMD is needed for the study, a single excitation, SEXA method, can be used. One of the unique features of the Digimus software is the automatic exclusion of a number of image features that would skew the analysis. This is the analysis of a mouse that was part of a study that examined BMD after fracture. The work was presented as an oral presentation at the 2019 ASBMR Abstract 1009. For the study, a metal pin was inserted into the femur that would be fractured. Without the ability to remove the signals from the metal, the BMD measurements would have been limited to ROI on the contralateral side of the mouse. Since the Digimus software is able to find the pin and then segment it out of the analysis, it does not skew the measurement of global BMD and body composition. There are analogous methods for the removal of wound clips and ear tags. The Digimus software also has a feature that determines the location of the skull and removes it from the analysis. The skull box can also be resized to exclude any signals from nose cones or anesthesia lines. Once removed, the skull box and the analysis values can be added back to the original image if required. The Kubtec Parameter 3D system uses tomosynthesis to show your specimen in 1 mm digital slices, giving you a detailed 3-dimensional view of the specimen's anatomy. In this acquisition, we are going to obtain 1 mm slices through a mouse. To do this, the system uses a laser to determine the height of the object, and then the software moves the X-ray source to create the required number of projections. You can move through the digital tomosynthesis slices of the mouse either by running a movie loop or manually selecting the slices you want to review. This mouse was part of the fracture study mentioned earlier. You can clearly see the pin in the femur as we scroll through the images. Now we'd like to present Kubtec customer testimonials. These valued customers will walk you through their experience using the Kubtec systems at their facility.
I'm Megan McGee Lawrence. I'm an associate professor in the Department of Cellular Biology and Anatomy at the Medical College of Georgia at Augusta University. I have a Kubtec parameter 3D system with the Digimus BMD software. So our Kubtec 3D parameter system is located in my laboratory, but we also function as a core facility for all of the musculoskeletal investigators here at Augusta University. So our system is used by a number of different PIs that are interested in tracking body composition as well as bone density measurements, and also those that want to take X-rays, whether a two-dimensional or a three-dimensional X-ray using the 3D functionality of the cabinet. The applications and procedures that we're primarily interested in using with this system are tracking body composition and bone mineral density. So we've done that now on a number of different animal model systems. Primarily, we study mice. So we do a lot of mouse-based studies where we want to track changes in fat mass and lean mass, as well as bone mineral density. But we've also used the system for animals as large as rats, or down even to zebrafish. So we've got a large range of models. We've also done some analyses with human cadaveric tissue, tracking bone mineral density in those as well, and some other larger animal models like rabbits. We do use the system for a lot of standard procedures like tracking bone mineral density and body composition, but we've also got some unique applications as well. One of the more unique studies we did was looking at changes in bone mineral density in zebrafish exposed to alcohol. And so the Digimus software was able to show a reduction in BMD with chronic alcohol exposure in zebrafish. We also use the system for tracking decalcification of our bone samples prior to histological processing. So we use more of the X-ray features for that. And we've also used the system to track refilling of bone defects in tibial defect models and some femoral defect models as well. The parameter system we've been using has been a great help in terms of our scientific progress. One great feature of it is that we can use it to monitor bone density longitudinally. And so it's been really helpful in collecting data sets for our grant applications as well as for our scientific publications, because it reduces the number of animals that we need to study. By being able to track these metrics longitudinally instead of cross-sectionally, we can do our studies with a smaller animal cohort and get the most amount of data from the smallest group of animals possible. When I was researching the different systems that I would want to add to my laboratory, I chose the Kubtec system primarily because of its functionality. When we were looking for a cabinet X-ray system, I was also looking for a system where we could measure bone mineral density and body composition. And the Kubtec system had the best options available. I was also really impressed with the company. We've had a great relationship with the company, and when I've had a question or a new feature that I'd like to see added to the machine, the company has been very responsive in helping us to work with the application scientist to develop the functionality that we need. As one concrete example of that, we did some studies where we had an overectomized mouse model. And of course, with surgical models, you sometimes have metal wound clips that are visible in the field of view. And that can be really problematic in terms of tracking things like body composition and bone mineral density. So we had a great relationship with the application scientist. We were able to come up with a solution for excluding any pieces of metal in the field of view so that we could get accurate data. The system we have in our lab is very easy to use. In fact, it's one of the first types of experiments that we train new personnel on. Whether we get new undergraduate research volunteers or new graduate students, getting them to work with the Kubtec unit is one of the first set of experiments that we have them try, because it's very straightforward to use and it's very easy for them to get quantitative data. So we train new personnel in how to collect the DEXA scans as well as analyze them. And that's one of their first contributions to the laboratory in terms of our scientific products.
Hello, my name is Ryan Ross. I'm assistant professor at Rush University Medical Center in Chicago. My lab purchased a Kubtec parameter with the DEXA software. We keep our instrument in our shared animal facility. We do that because we've implemented our instrument as part of our X-ray imaging core facility here at Rush. And in addition to my own lab, on any given project, we may have as many as 10 people using that instrument routinely. Our applications vary. We have people that do routine mouse X-ray imaging. longitudinal DEXA imaging for both BMD and body composition, as well as we have a number of groups that use the X-ray imaging facility or instrument to guide preclinical orthopedic surgeries. Here I'm showing some data from actually last year's ORS poster from my lab, and it shows one of the applications that we've been routinely using the parameter for, and that is to help guide in some preclinical orthopedic surgeries that we're doing. So in this model, we're trying to understand implant fixation. And this is a rat model, and part of our surgical procedure is to implant a titanium rod to simulate an implant, orthopedic implant, in the distal medullary space of the rat femur. So using this system, we're able to obtain pre and post-surgical images to identify whether we're appropriately placing this implant. As you imagine, this is a relatively small area that we're trying to target. We can assess the success of our surgery. So in this particular experiment, we were comparing a regular Sprague Dawley rat to a diabetic model. So this is our obese diabetic model, and you can see, which you can obviously pick up some of that here in our X-rays. And as you'd expect from an ORS poster, we're showing two animals that had quite good implant placement. So some of the maybe unique applications that we've been working with, and as part of the core in particular, a collaborator has been interested in performing ex vivo DEXA measures on large animal samples. So we're looking at sheep and pig bones and trying to optimize our system to obtain BMD measures of those larger animals. We also have a collaborator at a local dental school that's very interested in using this system to assess periodontal alveolar bone density in the periodontal space in these animals. So not just the axial or appendicular skeleton, we're also shifting to more craniofacial as well. So when we purchased our Kubtec system, it was actually in the goals of replacing a system that had gone down. So in our original conversations, we had reached out to the manufacturer of that previous system and found Kubtec as well, and compared primarily what really drove me to the Kubtec system was the quality of the customer service and the technical support. I feel as it felt at the time that Kubtec was both responsive to my questions, very detailed in their applications. The system is quite easy to use, easy and rapid. We've taken advantage of that, especially as many of our surgical applications, the animals are anesthetized and we're trying to move quickly. So being able to start that system and get a very rapid and optimized X-ray quickly is something that we rely on. Similarly, when we're obtaining our DEXA measures, many of them are longitudinal. We're trying to run through large numbers of animals all at one time. Usually these are done by students, so they are working individually, not a lot of extra help, and just the ease of use of the software makes it possible for someone to obtain large amounts of data really rapidly with these longitudinal measures of live animals. So we found it very easy to use. We found it very quick and requires very little hands-on optimization on our end, which we appreciate. As a junior investigator and the manager of our imaging core, I've found the Kubtec system to be quite simple to use, rapid, reliable, and the customer service, technical support to be phenomenal. We've had any of the challenges that we've had with this instrument have been immediately addressed, and it's constantly used by a number of research groups here at Rush to complement their research activities. We have a number of pending grants that are under review that are utilizing this software, and we anticipate continuing to do so based entirely on the functionality and the reliability of this instrument.
Thank you for your time. We are pleased to continue to support the ORS. Should you have any further questions or would like more information, please visit us at www.kubtecscientific.com.